This problem is going to use integration for rational functions. Remember, a rational function is just a polynomial over another polynomial, and that's exactly what we have here. Now, whenever we do that, we want to make sure that, first of all, the degree of the top polynomial is smaller than the degree of the bottom. And that's true here. The degree of the top is 2, and the degree of the bottom is 3, so we're fine there. We don't have to bother with any polynomial division to start this off. We can go right away and start to factor the bottom. So when we have 2x cubed plus 3x squared minus 2x, we see right away there's a common factor of x. We can pull that out front. And that's what's left over. And this quadratic, we can factor that. We need to put a 2x here and then x there. And we'll put a 2 here and a 1 there. 2 times 2 is 4, and we want that to be a positive. And then minus 1 times x is minus x. The 4x and the minus 1x give us the 3x. And the negative 1 times 2 gives us the negative 2 here. So that denominator is fully factored now. And now we can start on the process of decomposing this into partial fractions. So it's x, 2x minus 1, x, 2x minus 1, and x plus 2. We're going to decompose that as a over x. That comes from right there. B over 2x minus 1, which comes from right there, plus c over x plus 2, which comes from the last factor. To make progress on this, let's multiply both sides by this denominator here, okay? When I multiply this side by the denominator, they just cancel off, and I'm left with x squared plus 2x minus 1. When I multiply this by this denominator here, the x's cancel off, and I'm left with my a as well as these other two factors. When I multiply this second term by this denominator, the 2x minus 1's cancel off. I'm left with the b as well as the x and the x plus 2. Finally, when I multiply the last term by the denominator here, the x plus 2's cancel off. I'm left with my c as well as the x and the 2x minus 1. Good. So let's take this equation here and plug in some well-chosen numbers to find out what a, b, and c are. So for my first factor, x here, what makes that 0? Well, of course, 0, right? So why don't we let x be 0 in this equation above and see what we get? 0 squared is 0, plus 2 times 0 is 0, and 0 minus 1 is minus 1. So we get negative 1 equals a. 0 in here, 0 minus 1 is minus 1. 0 plus 2 is 2. And when x is 0, this entire term gets wiped out. This entire term gets wiped out. And what do we have left? We have negative 1 equals negative 2a. And that means a is 1/2. So that's a good start. What should our next number be? Let's take x to be, say, negative 2. That'll make this one 0, right? So we would get negative 2 squared is 4. 2 times negative 2 is negative 4. Minus 1. Well, when x is negative 2, this entire thing is 0. This entire thing is 0. And when x is negative 2, what do we have here? We have c times negative 2. 2 times negative 2 is negative 4. Minus 1 is negative 5. And what does this give us? Well, 4 minus 4 is 0, so we just have negative 1 left there. And over here we have positive 10c. So that means c is negative 1 over 10. Good. For our last number, let's let x be the number which makes this factor 0, which is 1/2. When x is a half squared is a quarter. 2 times a half is 1, minus 1. X being a half makes this 0. So, and over here we have b times a half. A half plus 2 is 5 halves. And when c is a half, that makes this 0, and therefore the entire thing is 0. So what do we have left over here? Well, plus 1 minus 1 just go away, so I'm just left with a quarter. And this is 5 over 4, so it's b times 5 over 4. Those 4's cancel, so it's really 1 equals 5b. So that means b is 1/5. All right, good. So we found our 3 values of a, b, and c. And now the integral should be very easy. So remember what the original integral was? It was the integral of x squared plus 2x minus 1 all over, it was, what was it again? 2x cubed plus 3x squared minus 2x, right? That was the question. So what was our first step we did? We first factored the bottom, right? We rewrote the bottom as just like this, x, 2x minus 1, x plus 2 dx. And then we broke this up into these 3 nice little fractions. A is a half, so this is really 1/2 over x. Plus b is 1/5 over x. And then c is negative 1/10. Whoa, sorry, this is not x. This is 2x minus 1. And c is minus 1/10 over x plus 2. And now everything is easy. Why? Well, because to do this integral, the half just comes out front, and we have the integral of 1 over x, which is the natural log of absolute value x. Here the 1/5 comes out front. And we have, well, we've got to be a little careful here. This is, if we write this, there's actually a little mistake there, right? Because when I do the antiderivative of this, there's a factor of 2, right? Or sorry, when I do the derivative of this, I have 1 over 2x minus 1 times 2. And I don't want that 2 to survive, so I need to put a power of a half, a canceling factor of 1/2 in front. So let me just fix this. Get rid of that. And we would have a half here. And then ln of 2x minus 1. And here the minus 1/10 comes out front. And here, since there's nothing in front of x, the coefficient is 1 in other words, I don't have to bother with that canceling factor. Plus c. Let's clean that up a little bit. So this is that. This is a 10th. This is a 10th too. We could combine those. I don't know if I'll bother. I think that's fine the way it is right there. We could bring this together, but I think I'll just leave it there. So there we go.